Alright, this is our pre-calc lesson 3.5 part 1. We're going to be looking at solving polynomial functions. We're still going to be using the zero product property, but we're going to be adding a new idea where we actually substitute a different variable into these equations. So in your notes that you have this first example where you are asked to find the GCF for each of these expressions. I want you to pause the video, go ahead, find the GCF for each, and then check your answer. Recognizing this GCF is going to be very important because that GCF is going to be what we actually assign as a new variable. So go ahead, pause, and do example 1. You got to check your answers. Letter A should be pretty simple. You have your GCF of x squared. Remember, check by multiplying back and make sure it takes you to what you started with. Now, letter B, we have to recognize that there's two terms here, and they're separated by subtraction. In each of those terms, we have a factor of x plus 2, so that's what we factor out. And what we're left with is the 4, another quantity of x plus 2, and the 3x. Well, that factor on the right, we can then simplify, distribute the 4, combine your like terms, so your final factorization would be x plus 2 times the quantity x plus 8. See? Here we can factor out, notice we have this e to the x. Now, I know this one has a 2x, so we got to remember when we multiply, we add exponents, so x plus x would be 2x. Same with letter D. This x cubed times 5x cubed would give us 5x to the 6, because when we multiply, we would add those exponents. Alright, letter E, I've shown you how to do this two different ways. You could use log properties, which first one, if we have something times log, we can rewrite it as a power. Then the difference we can rewrite as a quotient, and then we end up with that quotient that can be simplified into log base 2 of x cubed. Or you could just factor out, you have log base 2 of x as a common factor, then you have left 8 minus 5, which is 3, so you have 3 times the log base 2 of x, which remember, those are equivalent by that power property of logs. Letter F, we have a common factor of x plus 3, and what's left is here is the 2x plus 3, that quantity to the third power, minus 3, and we don't have to simplify this. Okay, so this new technique that we're going to call chunking, the common chunk is going to be that GCF. It's similar to a GCF. It's a way to rewrite something that's common in a couple of terms with another quantity. And we want to replace that chunk with a different letter. Now, I'm not going to use Y. I'm going to be using A so that we don't get confused with, thinking that we're rearranging an equation, something like y equals 3x squared plus 5. We're going to solve that chunk, or that new equation for A. Then we're going to set that equal and then solve for that value of x. So here's an example. Here what we have, we're going to look in these two terms, and we have between these two terms, we have a common factor of x squared. So we're going to simplify this by saying that a is equal to x squared. So now we really have a squared minus 7a plus 12 equals 0. In other words, we're taking this fourth degree trinomial and rewriting it as a second degree trinomial. Now we can factor this, 12 and negative 7. We'd end up with negative 4 and negative 3. Coefficient here is 1, so we would just divide by a. So our factors would be a minus 4 and a minus 3, which will give our solutions a equals 4 and a equals 3. Now remember, we started with x's, not a's. So now we're going to set that chunk. Remember, a was really x squared, so now we'd have x squared equals 4 and x squared equals 3. So we'd solve this by undoing the square, which would be a square root, so x will equal, and here we need to be careful, we have plus or minus the square root of 4 and plus or minus the square root of 3. We know the square root of 4, it'll be plus or minus 2, and we can just leave this one as x equals plus or minus square root of 3. So that fourth degree equation that we started with would have 4 answers: 2, negative 2, root 3, and negative root 3. Another example, we're going to kind of approach this in just a little bit of a different way, and that we want to use that substitution to kind of simplify this. We want to get it into this form, if we can. So first thing is we need to get rid of this 22 to get 0 on the right side. So we're going to subtract 22. So we end up with this x to the 6 minus 3x cubed, and that will give us minus 40 equals 0. So when we look at these first two terms, we should see that we have this x cubed term that's common. So we're going to say that a equals x cubed. So then we can rewrite this as a squared, because x cubed squared would be x to the 6, minus 3a minus 40 equals 0. Now we can factor this, and we need two numbers that multiply to give us negative 40 and add to give us negative 3. They would be negative 8 and positive 5. So we end up with the solutions of a equals 8 and a equals negative 5. But remember, we started with x's, so now we need to go back to that original substitution idea. So x cubed must equal 8, and x cubed must equal negative 5. Now just think about this. Can we cube a number and get a positive? Yes. Can we cube a number and get a negative? Yes. So to solve each of these, we're going to take the cube root, so we get x equals 2, cube root, so x will equal the cube root of negative 5. Erase that. So we only have two answers for this, and they are 2 and the cube root of negative 5. And we could check each of these. If we take 2 to the 6 minus 3 times 2 cubed minus 18, we better get 22. Grab your calculator. Grab mine. And I do 2 to the 6. And I get 64 minus 2 cubed is 8, 3 times 8 is 24, minus 18 does equal 22. We could check the cube root of negative 5. If I take the cube root of negative 5 and raise it to the 6th power, minus 3 times the cube root of negative 5 cubed minus 18, better get 22. This was a check, by the way. So this would end up, this is like a 1/3, or another way to write that is 1/3. 6 times 1/3 would be 2. So we have negative 5 to the power of 2, which would be 25. This cube and cube root undo each other, so we have the quantity of negative 5 times negative 3, which would turn into plus 15, and then minus 18. And we check that work. 25 and 40 and 15 is 40, minus 18 is 22, and that does check. Okay, I'm going to leave C and D in this set, as problems for you to do on your own. Oh, what happened? Hold on.